Hi everybody! 2 lessons ago we learned that central angles are equal to their intercepted arc, and that's what we see right up here in the first example. X, the degrees in the central angle, are the same degrees as the central arc. You can see that we marked an arc for this angle. We could mark an arc farther out and farther out. And as you go out farther, eventually you'll be right on the edge of the circle, which is that arc. So you can see it doesn't matter as long as it's a central angle. Where you measure it from, it will be the same. However, last time we learned that with an inscribed angle, you can see that as you go out and out and out and out, it gets bigger. And this is much sharper when it's on the edge as an inscribed angle. We learned last time that the inscribed angle is only half of the arc that it intercepts. So in this case, half of 100 would be 50. So X would be 50 degrees. Okay, looking down here. Special situations involving inscribed angles. An angle inscribed in a semicircle is always a right angle. So here's a semicircle. It's going straight through as a diameter, and its endpoints are on either end of that diameter. It will be a right angle every single time. It doesn't matter where they measured it from. Let me just show you. Say that we had another point that maybe we'll put a D right here. And let's draw, whoa, like that. There's our point D. You can see that even though I've drawn it badly, this would still be a right angle. And this would be a right angle. As long as your endpoints are on the ends of the diameter, it will be a right angle. Okay, going on to the next example, a quadrilateral inscribed in a circle is called a cyclic quadrilateral. The opposite angles in a cyclic quadrilateral are supplementary. What that means is that they will add up to 180 degrees. So this X plus Y, because they're opposite angles, will add up to 180 degrees. You could also say that angle B plus angle D would also be 180 degrees because those are opposite angles. All right, so case number 4, angles formed inside of a circle by 2 intersecting chords. Here's a chord, here's another chord, they cross. We know that one of the things we know is that vertical angles are formed when 2 straight lines crossed. So that angle E would also be equal to angle X, but we don't know exactly how much they are, but we can figure out what they are. Here's the formula over here. If we want to know what angle BED is, here's B, there's E, there's D. What we need to do is add up the 2 arcs. So arc AC added to arc BD, so 70 plus 170, and then take half of it. And then we'll know what one of these are, and then also the other because they're the same. So 70 plus 170 equals 240. And then, like the formula says, after we add them up, we take half of it. So when you take half of something, you divide it by 2. So let's divide 240 by 2. That means that we end up with 120 degrees. So this guy right here, angle ACEA or AEC, however you want to say it, that's 120 degrees. And so is this one. They're both 120. Okay. All right, that's what happens when your angle is inside the circle. Now we're going to get some cases where the angle's outside the circle. Now this is very similar. The difference is you're going to subtract the two arcs. See, the formula says subtract 260 minus 100 and then take half of it. So if you've got 260 and you take away 100, then you've got 160. And then if you take half of that, you divide it by 2, and that'll be 80 degrees. And so that's how they came up with 80 degrees right there. What that means is that this x, this angle right out here, equals 80 degrees. Okay. When you have two lines that are going through the circle, you've got, this is called a secant that goes right through the circle. And they work the same way. You can see the formula takes the two arcs that it intercepts and subtracts them, and then takes half of it. So here we have 80 degrees, here we have 20 degrees. They subtracted it. 80 take away 20 is 60, and then if you take half of that, you'll have 30. And that's how they arrived at the fact that this x out here is 30 degrees. Let's go back and compare these two new skills that we learned. We have two different skills. They look different because your angles are in the middle of a circle. They're inside the circle. And when they're inside, you add those two arcs. So we had to take 170 and add up 100, add up 70. When it's outside, either you've got two tangents to the circle or you've got two secants. Those arcs get subtracted. One of the ways that I remember that really has nothing to do with math, but it helps me remember, is if you're included in the circle of people around you, you are happy, you are positive. Look at that. This angle is inside the circle, it is positive. So you're going to add them. But if you're outside, sometimes that's not such a happy thing. It's kind of negative. So be thinking that if the angle that you want to find is outside of the circle, you're going to subtract. Okay, that's it for notes. Let's go on to our work that's assigned. Let's solve. So number 1, review skills that we learned before. This is the center. You know it's the center because you've got that dot that marks it as the center. Central angles are the same. So question mark equals 115 degrees. No math involved, you just have to remember that fact. Okay, number 3, a similar skill. This is marked as the center. Central angles are the same as their intercepted arc. So again, you don't have to do any math. You just know they're the same. So question mark equals 140. Okay. Now with number 5, we have a little bit of a different skill, just learning to recognize the angle that they're talking about here. UVT. Here's U, there's V, there's T. So they're talking about this angle right here. They have given us a little bit of a puzzle here, but they've given us some clues. First of all, we know this is a diameter. And diameters make half circles, and half circles are 180 degrees. So let's write that up here because we know that. Then they gave us that from T to S, this arc is just 125 degrees. I want to find this distance from U to T. So I have 180. I'm going to take away 125. And that's going to give me 55 degrees. I'm going to write it up here. And then it becomes a problem just like we just did in number 3 or number 1, where we have to remember that the angle we want is the same as its intercepted arc. So the measure of angle UVT equals 55 degrees. The same as its intercepted arc. Okay, now let's look at number 7. We have the measure of arc VTU. The measure of arc VTU, it's important that we do direction here. We want to go from V first to T, then to U. Remember, major arcs need 3 letters because they need to show you which direction they go. You're going the long way around. Okay, now this is not a hard problem because straight lines and half circles are 180 degrees. If this is 180 degrees, its intercepted arc is also 180 degrees. And then they gave you this little piece, this little intercepted arc from U to T is 45. So you're just going to add the total together. 180 plus 45 is 225. Okay. Let's go down to number 9. Number 9, find the length of the segment indicated. Round your answer to the nearest tenth if necessary. Okay, for number 9, what we need to remember is a squared plus b squared equals c squared, our old Pythagorean theorem. And I'll just write it up here. Remember that the right angle always points to the hypotenuse, and the hypotenuse is always c. This then would be a, and this is b. We need to find this length right here. So I'm going to plug in a squared is 9.1, and we square it. B squared, we don't know, so just leave it as b squared. C squared is 15.5, and we square it because of the formula. We can go over to our calculator and square 9.1. And that's 82.81. So I'll write that in. And 15.5 squared is 240.25. Okay, to solve for this b, we want to get b squared all alone first, so let's get rid of 82.88 by subtracting 82.81. And so those cancel out, and that leaves b squared all alone on this left-hand side, and we can use our calculator. 240.25 take away 82.81. Okay, so that's 157.44. The way we get rid of a square is by taking the square root. So we come on over to the calculator. Sorry, I meant to write a B, not a 10. Come on over to the calculator and take the square root of 157.44. and that's 12.5. It says round to the nearest tenth. That 4 is not enough to make it go up to 12.6, so B equals 12.5. And now we really are done, because when we have a perpendicular line, it's going to cut that chord that it intersects in half. So B is the same as X. This is going to be 12.5 as well. Okay, let's try another one. 11. This one you'll also need to do it the very same way. So let's just review that. First of all, a squared plus b squared equals c squared. Good old Pythagorean theorem. And right angle always points to the hypotenuse, so there is C. Here's A. This side that we don't know is B. So we're going to put in for A 5.2 and square it because of the formula. B squared we don't know, so leave it that way. C was 13.9 and square it. So in our calculator, 5.2 squared is 27.04 plus b squared, and again we'll square that 13.9. Oops. And that's 193.21. Now to get b squared all alone, we need to take away this 27.04 from both sides. B squared will equal that difference there. So 193.21 take away 27.04, and that is 166.17. Notice I'm not rounding yet. The numbers aren't too crazy. I can deal with two places after the decimal. So I'm just keeping it this way. Now I'm going to square root to get rid of that square. That leaves b all alone, and b will equal the square root of 166.17. Okay, which is 40.81 and a whole bunch of other numbers. We're rounding to the nearest tenth. 8 is in the tenths place. 1 is not enough to make it go up to a 9, so the answer here, the distance that b equals, is 40.8. And just like we talked about before in the other problem, this b length is the same as this x length, because whenever you have a right angle here, it's going to cut that chord in exactly half. So x is going to equal 40.8. Okay, everybody. Number 10 is exactly like 9 and 11 that I just worked for you. Please try that one on your own, and then I'm not going to make you do number 12, so you can cross it off. Let's move down to the next skill. In this section, we're finding the measure of the arc or the angle, depending on what they ask for. In this case, they have a question mark over here by the arc, so they want this great big intercepted arc right here from R to Q. We remember that inscribed angles are half of their intercepted arc. So if I want to go out from the angle going to the arc, I need to get bigger, because this guy back here is only half. So if he's half, I need 2 of them. Let's times them by 2. So 95 times 2 is 190. So R to Q is 190 degrees. Okay, let's look at number 15. Number 15's question mark is right in this angle L spot. So that's what they want us to find. We know that angle L has its rays coming out from R, going to R, and then going up here to Q. And the arc that it intercepts is 92 degrees because they gave us that. Now remember that the angle in our former problem was half of the intercepted arc. That's still going to work over here. This time though, they gave us the intercepted arc, so we need to go back to the angle. So when you go backwards to the angle, you're getting littler. You can see how sharp that angle gets. That's another way to just visualize that it's getting smaller. So we need to divide by 2. So 92 divided by 2 is 46 degrees. Okay. 14, I won't do it for you, but I will talk about it a little bit. They gave you the arc from B to C is 90 degrees. You're going back to the angle. So you're getting smaller. You're going to divide. Okay. Looking at 16, they gave you the angle. And it goes out to the intercepted arc. It's getting bigger. So multiply by 2. Okay. All right, to the next skill. Find the perimeter of each polygon. Now these are kind of long. I'll walk you through one and then I'll assign one, but that's all in this section. One of the things that we do know is that when we have 2 tangents that come out and touch the circle, these 2 tangents will be the same. So right now, I don't know anything about these 2 specifically, so I go to where I do know maybe just a half of the length on one side, like up here. Look at 7.7. I know that from that dot to that corner is 7.7. Since its other tangent that's on the other side of the angle, since they're both tangents, they'll be the same. So this is 7.7 as well. Okay, now let's come on out here. This is 8.4, and that means from here to here is 8.4. That's useful information. So I'm going to write it out here, and that will help me figure out what this was. Remember, we didn't know what it was. We know that the whole length is 14.8. If we know that this little piece over on the left is 8.4, then you're going to subtract. So 14.8, take away 8.4. Is 6.4. So this little piece over here, I'm going to write in its measure is 6.4. The other side of its angle right here is also the same because they're both tangents. So we'll write in that that is 6.4. Okay, we're almost done. And I bet you can see what we're going to do here. If we know that the bottom piece is 6.4 and the whole length is 18.4, we do the same thing. We take the whole and we subtract the piece that we know. And so the remainder is 12.0 if you want, but it's just 12. And then if you look at the angle, both of these sides of the angle are tangents, and so they are the same. So I'm going to write in this 12 right here. Now you see all the little pieces that we can use to add up to find the perimeter. Remember, perimeter means the whole way around. So 7.7 plus 7.7 plus 8.4 plus 6.4 plus 6.4 plus 12 plus 12. Add up all those blue numbers that we just wrote in, and the one that we started with, of course. So if you add up all the little pieces that you know, you will have the perimeter. So I'll leave that to you to do with your calculator. That equals, I don't know, something. Go ahead and do it. Let me start you talking about number 19, and just the same, I won't finish it for you, but we'll start. One of the things that we can do is start with what we know. We know that this piece is 8.4. That means that its other side is going to be 8.4 as well. I'm going to write that in right here. But that only takes me so far because I didn't know anything about this remaining side. So I'm going to look over here and see if I know anything over here. So this piece they gave us is 9.5. That means its other side of the angle is 9.5 as well. If this little piece is 9.5 and the whole piece is 20.5, then you're going to subtract and you'll find out what this piece is, the top part of this side, and then its pair will be the same. Then when you're done, you just add up all those pieces. So I'll let you finish up number 19 on your own. You do not have to do 18, you do not have to do 20. Okay, let's go look at the next skill. The section starting number 21 says, find the segment length indicated. Assume that the lines which appear to be tangent are tangent. Okay, one of the things that we know about a tangent and where it connects to the diameter is that they always make right angles. So here's a right angle. And that means whenever we have a right triangle, we can use Pythagorean theorem. So I know that this is 3.2. The hypotenuse, though we need to find that first, is the 6.8, and that becomes the C. Your 3.2 is either your A or B. It doesn't matter which one you label it. And then we're going to use the A squared plus B squared equals C squared. Good old Pythagorean theorem, useful for lots of things. Okay, 3.2 will go in for A, and we square it. The B is what we are trying to find, so we'll leave it as the variable, B squared. The C is 6.8, and we'll square that. Okay, coming over to our calculator, let's figure out what 3.2 squared is, and that's 10.24. And then we also need to come on over and figure out what 6.8 squared is, and that's 46.24. We want the variable all alone, so we subtract away 10.24 on both sides. B squared equals 36. And then the square root of B squared is the square root of 36, and you guys know 6 times 6 is 36, so the square root of 36 is 6. And that's done. Okay, let me talk you through a few of these, but I'll leave it up to you to finish them. Number 23, again, tangents, when they, this is a tangent because it touches a circle, when they meet up with a diameter, they always make a right angle. There's your right angle. It's pointing up to your hypotenuse. Your hypotenuse is C. Your short leg out here is A. There's B. Then use Pythagorean theorem. like before in number 21 to solve that one. Okay, number 22 is just a little bit different, but let me start you out by talking about it, then I bet you can finish this one. One of the things that you have to remember is that all radii, wherever they are always the same. It's kind of like a wagon wheel. If you had a radius on a wagon wheel that was not the same as another, you'd have a wobbly wagon. So this 12 is the same as that radii, which is 12 also, and that helps us a lot. Now I need to know where my hypotenuse is. So let's draw our right angle. There's our tangent. There's where our diameter would be. And it points up here. This is C. I'm going to label it as C, but this piece is 8, this piece is 12. We need to know what they are all together, so we add them. This hypotenuse length then is 20. Okay, remember this can be A or B, it doesn't matter. We've been solving it where we have the number first, so maybe I'll call this A and call that B. Then you can set this up with our good old a squared plus b squared equals c squared, and you'll know how long that tangent is. Okay, one last problem. Number 24 just takes one step before we can do what we did in number 21. They've labeled the radius as 6. The radius is only a piece of this side of the triangle that we're using. Remember, radii are the same length, just like as we discussed in the last problem. So there's 6 up there as well. This whole side then is 6 plus 6, which makes it 12. Here is our tangent. Here is our diameter. Tangents meeting up with diameters or radiuses, radii, always make right angles. So there's our right angle, and it is pointing up to our hypotenuse, and that's C. We'll label this A and B. And you'll solve this one a little bit different, because in this we'll have the two numbers on this a squared plus b squared side. So instead of subtracting, you'll end up adding these together, then taking the square root to find C. Okay. All right, everybody, good luck.